Hello, everyone. So we're back talking about mass volume and density. I want to make sure we're very clear about these variables moving forward. So mass, as we've talked about, is your measure of the amount of stuff, if you will, in an object, and we measure mass in grams. Um, there are three different states of matter, which I'm sure you are aware, the solids, liquids, and gases, and we're going to talk a little bit about um, their densities later on in the slideshow. So volume, um, being the amount of space an object takes up, can be measured in two ways. One is shown here using length, width, and height for a regular object, or we could use water displacement in order to measure an irregular object. Liquids often are measured in milliliters because we would use a graduated cylinder. So volume has more than one unit, and they are equal. 1 milliliter is equal to 1 cubic centimeter. So density refers to both of these other properties, both mass and volume, and shows you the compactness of matter, which you can see in the two pictures on the bottom. The one on my left here, let me go to my pointer, would be more dense, more compact within the same amount of volume compared to this substance over here, which is less dense. The molecules are less compact within that same space. So we define density as the amount of mass within a given unit of volume. Okay. And that's exactly what it's measuring. How compact is the matter within this space? When we were talking about in one of the class questions, I showed you a picture of a density column and asked you to tell me which part of the column would represent the liquid with the lowest density. Okay, so you can actually mix liquids, and I'm hoping to attempt this at some point, so that they stack based on their densities. Okay, your highest density liquid, the most compact matter within a certain space, would be at the bottom, followed by your lightest being at the top. Okay, objects that are more dense sink, and objects that are less dense will float. And of course, that is going to be dependent on a couple of factors. If thinking about liquids, this here, mason jar, would be representing our liquids density column. Which of these liquids would be the highest and which would be the lowest? So based on what we just talked about, the most dense sinks or would be towards the bottom, and the least dense would be at the top. Okay. If you were given the densities of the various liquids within this density column, you could then figure out the density of each liquid and arrange them to represent that. So if you were looking at the fact that we have 10 grams per cubic centimeter, 6, 5, and 3, could you list out, looking at this mason jar, where each of those densities would be? Least dense on the very top, followed by the next, more dense, and then more dense until we reach the one with the highest density. Okay. Density will determine whether or not an object will sink or float within a liquid. Of course, you have to know the density of the liquid to determine whether an object would float or sink before actually putting it in. Based on these pictures here, it's very obvious that the rock is more dense than the water because it immediately sinks versus the cork floating nicely at the top. So an object that is more dense than the liquid will sink, and an object that is less dense will float. Now, in order to calculate density, we need to know two variables. You need to know the mass of the object, and you need to know the volume of the object. And again, there are the two different ways we find volume. You can use length, width, and height, or water displacement, where you would read the volume of the graduated cylinder with nothing in it, drop your object in, and then read the volume of the object, the volume of the graduated cylinder again, and simply subtract the two to find the volume of the object alone. And then it's a really simple division. The mass, which we measured in grams, would be then divided by the volume, which could be measured in cubic centimeters or milliliters. Again, they're equal. And that would give us our answer. And you need to remember, when calculating density, to always include the units that you are using. Typically for solids, we talk about cubic centimeters, whereas for liquids, we would use milliliters, but either are interchangeable. So again, if we're going to go through the process and do a quick example problem, right, we found the mass of the object in the given example was 35 grams. You find the volume of the object, and then in the given example was 7 cubic centimeters. So then you simply have to divide these two. So I start by writing out what my knowns are. I know the mass is 35, I know my volume is 7, and I know I need to take mass and divide it by volume. When I do that, I get a really simple answer of 5 grams per cubic centimeter. You can see, much like in the equation where mass is over volume, so should your units be grams over cubic centimeters in this case. Another way to think about how to do these calculations is with a density circle. Okay, we have the same variables that go into our density equation, and we use what I like to call the circle T method. Okay, in this particular case, mass is always on the top of our circle, density and volume are always on the bottom of our circle, and it helps to dictate what you do when solving for any of these three variables that may be missing. In this particular problem, you can see that we are given the mass of the block of aluminum and its volume. So again, mass would go on top. So I have 40.5 grams on the top of the circle. And I'm given my volume, which is 15 milliliters, and that is on the bottom circle. The line between the two represents dividing. You would divide the top by the bottom and come up with your answer of 2.7 grams per milliliter. It's just another method for helping to solve these problems. In this particular problem, I know my density for the ethyl alcohol, and I know the volume of the alcohol that I have. What I'm trying to discover is the mass. Okay, so in this particular case, I know my volume is exactly 200 milliliters and that my density is 0.789 grams per milliliter. Now, when the two are next to each other, we simply multiply these two together. So when they're next to each other, we're multiplying them. And when we do that, we end up with 157.8 grams, and that is the mass of this sample of ethyl alcohol. And we could find that knowing these other two variables. Again, just solving for volume this time, we are using the circle to show how we can manipulate the information we have to solve what we don't. We know the mass of the piece of silver, and we know the volume, density, of the piece of silver as well. So we can figure out exactly how much space this takes up. So in this particular case, again, our mass is over the density, and so we would divide. That fraction bar is a division bar. And when we divide the 2500 by our 10.5, we would get the amount of space that that block of silver took up, and that is the 238.1 cubic centimeters. Okay. Again, just one more practice problem. Okay, we're trying to figure out the density of this particular paperclip. Using our equation, we want to find density, so it's very simply mass divided by volume. We took the mass of 9 grams and divided by the volume of 3 milliliters, and very simply get a density of 3.0 grams per milliliter. You are welcome to show your work in any way you want using either the equations, or if you prefer to use the circle method, you can use that as well, where you would draw out the circle T and simply using the circle, you would put your mass here up atop, so that's your 9 grams, followed by placing the volume on the bottom, and again, you're doing the same math. It's still a division. Looks a little bit more like a fraction at this point, so it's 9 divided by 3, which then gives you the density of 3 grams per milliliter. So there's two different ways you can choose to show your work to solve for any of the three variables, either density, mass, or volume, in um, a problem. Okay, I don't mind which you choose to do. It's up to you, but you need to make sure you're showing your work on your calculations, please. Now, density, when we're looking at the different types of matter, spans a range. So most solids will fit within a certain range of densities, and that goes the same for liquids and for gases as well. And so you'll notice that solids and liquids fall within generally the same range. Most solids and most liquids are somewhere between 0.5 and 20 grams per milliliter. Gases, however, are much less dense. Okay, gases are very, very small densities because their particles are very, very spread out. And so they tend to have densities that are very tiny, so much less than thousandths of grams. Okay. Now, density is what we call a characteristic property. It is a trait that identifies a substance and always stays the same. So in one of the last activities, I had asked that you use the density to try to identify what those metal cylinders were made of. Okay. Now, when we talk about stays the same, it means that everything has to be measured under the same conditions for those properties to actually stay the same. So if the density of a gas is being measured, we have to know the standard temperature and pressure under which it was measured. Okay, so there are exceptions for looking at characteristic properties. We need to know the environmental conditions under which they were measured to make sure you're mimicking the conditions. Here's a nice little link that just shows how changing pressure can affect boiling point. It's a really fast little video. I suggest you go into the PDF I shared and go ahead and check that out. And just some other examples of characteristic properties are density, boiling point, melting point, freezing point, and solubility, the temperature at which a substance will fully dissolve into a liquid. And that, my friends, are all of the notes that I'm going to give you today. You do have some practice problems for density that I need you to do as well. And if you have not completed the hypothesis for our next lab, you need to do so before next class, please. Okay, have a great day.